Hello, algebra students. Mr. Lawrence here, and this is going to be a real quick video. We're just spending a little more time on absolute value inequalities and actually threw an equation in there, and then we're going to do something that's kind of cool. Um, we're going to go backwards. We're going to take the answer and see if we can write the absolute value inequality. But let's quickly review that on problem number 1 here. This is an AND problem, right? Because it's a less than. All right, and this is an OR problem. Number 2, that is. And you may not remember, I mentioned in the video eating game practice, equals are also OR problems. So I'm actually going to start with problem number 3. I'm going to solve it just like this. I'm going to say x plus 5 equals 6, or x plus 5 equals negative 6. And I'm going to subtract 5 to get x equals 1. And then I'm going to subtract 5, and I'm going to get x equals negative 11. And if you graph that on a number line, it would be a real simple graph. Negative 11, you got 1, and you would just have a point on each of them. There wouldn't be any shading because there's only 2 answers. Okay, that's what an OR looks like. Should be real simple for you. I don't want to spend a whole lot of time on that. An equals, that is. All right, so let's go and do number 1. It's an AND, so I'm going to do x minus 12 is less than 9. And then over here, I'm going to put negative 9 is less than the x minus 12. I'll add 12 to all 3 parts. And I'm going to get 3 is less than x, which is less than 21. To graph that on a number line, of course, I have to show 3. I have to show 21. My points are going to be open because it doesn't say equals to. And I'm going to shade in between them. And there you go. All right, the greater than over here in problem number 2, I can do x plus 2 is greater than or equal to 8, or x plus 2 is less than or equal to negative 8. I'll subtract 2. I'll get x is greater than or equal to 6. Over here I'll subtract 2, and I'll get x is less than or equal to negative 10. And I'll put my OR statement in there. My number line, negative 10, 6. Points are closed. And from what I've learned in math class, yours have to go out like that, and have to go out like that. And there you go. All right, let's take a look at this other type of problem. Here I have the graph, and I'm going to see if I can come up with the absolute value inequality. I'll tell you the first thing I'm going to do is I'm going to find the midpoint. All right, I'm going from negative 6 to positive 4. I don't know if you know this, but to find a midpoint, you can add the endpoints and divide by 2. I mean, all I'm doing is finding the average, right? Oops, I wrote a 2 there. I should have written a 4. All I'm doing is finding the average. Well, isn't the average, when you're only dealing with 2 things, isn't the average smack dab in the middle? Isn't the midpoint of the segment smack dab in the middle? Now, some of you are going to go, well, Mr. Lawrence, all I had to do was look at it, and I knew the middle was negative 1. Yes, I know, but you need a way to be able to check yourself because that's not always going to be the case. It's not always that obvious to find the middle. So, you can add the endpoints and divide by 2 when you're finding a midpoint. All right, now, here's my midpoint. How far are the endpoints from the midpoint? Well, I think they're both 3 units, right? I'm going to use this information to write my absolute value inequality. Now I know I'm going to have an absolute value of something. I know the picture is an and. It's not a less than or equal to because my points are open. I'm going to need in here an expression that will turn to 0 if I put this in its place. What expression would turn to 0 if -1 were put in for x? Well, I do x plus 1. Do you agree with that? If I put -1 in for x, I get 0 inside my absolute value, right? So that's how you get the inside part. The outside part is simply the distance that the endpoints are from the midpoint. If you wanted to check it, you could solve it. All right. So I'm going to get what x plus 1 is less than 3, and it's an and. I'll subtract 1. Uh-oh, I've made a mistake. Tell you what, I must have looked at the wrong notes. Hold on one second. There we go. I found my mistake. You guys probably found it a long time ago. I looked at another problem from my notes, and I didn't even bother to check. This distance isn't 3, it's 5. All right, and therefore that changes that. Sorry about that, guys. Okay, so let me recheck this, and I'm going to get x plus 1 is less than 5, and then -5 is less than x plus 1. I subtract 1 from all three places. In the middle I get x. The left part I get -6, and here I get 4. Sorry about that. I didn't tell you anything wrong other than I miscounted my distances. So remember, this number here is the endpoint's distance from the midpoint. How far is the endpoint from the midpoint? Okay, so distance from midpoint. The expression in the middle turns to 0 if the midpoint equals x. So if you plug, in other words, if you substitute the midpoint in for x, your expression equals 0. All right, let's look at one more here. Looks like my endpoints are 0 and 8. I know it's going to be a greater than or equal to, right? Okay, so let me add 0 plus 8, divide by 2, and I'm going to get 4. I'm supposing that 4 is in the middle. Do we agree with that? Let's see, 1, 2, 3, 4. 1, 2, 3, 4. Yeah, 4 is the middle. Okay, and it looks like in this case that we're 4 spaces away on both sides, right? So I know I'm going to need a 4 here. That's my distance from the middle. And then in the middle, I need an expression that will turn to 0 if x is positive 4, the green 4. Well, x minus 4 would turn to 0, wouldn't it? So to solve this, just to check and make sure I get the picture I'm supposed to get, x minus 4 is greater than or equal to 4, or x minus 4 is less than or equal to -4. I'll add 4, x is greater than or equal to 8. Hey, that looks like that part of the graph, doesn't it? Or add 4 to each side, x is less than or equal to 0. And that looks like the other part. And of course my solution is actually this for my check. But this is the answer to the question. All right, that's it for today's lesson. Have a good night, everybody.